Okay, this is January 2008, question 3. So we've got the situation of a block resting on a rough plane, which means there must be friction acting. And attached to the block is a string, which moves over a smooth pulley, and there's a weight on the end. Clearly, if this weight was to drop, it would pull the block this way, which is why I've put the friction acting that way. We would also have a weight, 15G, and we would have a normal reaction of the ground on the block, which I've called R. There would be a tension in the string acting this way, and the same value of T there, because this is one continuous piece of string, so the tension is the same throughout. The weight of this block, this particle here, is mg. Alright, the system is in equilibrium, and the tension in the string is 58.8 newtons. So we've got that T equals 58.8 newtons. The sphere has mass m, calculate m. Okay, so if the whole system's in equilibrium, then this part of the system is in equilibrium, which means that these two forces must be equal. If this was greater than this, the object would be moving up. If this was greater than this, the object would be moving down. It's not moving, it's in equilibrium, so these must be the same. So we can say that T equals mg, which means 58.8 equals m times g, which is 9.8, and that gives the value of m as 6 kilograms. Okay? Now, question 2, calculate the frictional force. Well, the frictional force is acting horizontally, so I'm going to resolve forces horizontally. So in this direction, we have a force F. So this is part 2. And on in the other direction, we have T cos 40. Those are the only forces that are acting horizontally. So that means F equals 58.8 cos 40, and that gives us a value of 45.0 newtons to 3 significant figures. Part 3, calculate the normal reaction of the block on the plane, so that's R. Well, now we'll need to resolve forces in that direction, because that's the direction in which R is acting. So upwards we have R plus T sine 40 equals downwards 15G. But of course we know that T is 58.8, so R plus 58.8 sine 40 equals 15 times G, which is 9.8. And from that we can work out the value of R, and that gives us R is 109 newtons to 3 significant figures. And that's the end of question 3.